Today with us for mock coding interview, we have Mohammed Fras, who is a YouTuber with 60K plus subs, and he recently joined Google, so he's working as Google SDE. So let's quickly start with the interview. But before starting, let me quickly tell you about the sponsor of the video. If you want to work for Amazon, then Geeks for Geeks has brought a Jobathon exclusive hiring challenge partnered with Amazon to fulfill your dream to work for different SDE roles. And the best part is that the registration for this hiring challenge is totally free. The event is going to happen on 5th of every month for the next 3 months. Don't miss out this exciting opportunity to get hired. In this challenge, there will be coding questions on DSA and MCQ questions on programming language. You can check out the registration link and the job description using the links in the description below. Do check it out and fulfill your dream to work in Amazon. So, Fras, this is your question. You can read through it and ask me any questions that you have.
All right. So there are several stones arranged in a row, and each row has an associated value, which is an integer given in the array stone value. All right. In each round of the game, Faraz divides the row into two non-empty rows, that is left row and the right row. Then Keerti calculates the value of each row, which is the sum of the values of all these stones in this row. Keerti keeps away the row which has the maximum value. Faraz's score increases by the value of the remaining row. If the value of the two rows are equal, Keerti lets Faraz decide which row will be thrown away. All right. The next round starts with the remaining row. The game ends when there is only one stone remaining.
Right.
Faraz's is initially, okay, my score is initially 0, yes, the maximum score that I can obtain. Yes. So there are several stones arranged in a row. Got it. And each stone has an associated value. So basically each stone is going to have a certain value.
Yes. Which is an Let me give you an example also to make things easier for you. So this is one of the examples. All right. You can let me know what according to you will be the answer of this.
Got it. So basically there are 6 stones and each stone have a certain value associated with it. Now I need to divide it into 2 parts every time until I have only 1 stone remaining.
Yes.
Right? Got it. And the part which is having the maximum sum will be thrown away.
Yes.
And what will be added to my score? Just let me have a look again. The score increases by the value of the remaining row. Got it. So what basically am I going to do is I have to divide it in such a way that because the maximum summation part will be thrown away and I will be left with the minimum one. So I should divide it in such a way that they're almost equal. Right? So in this example, the sum here till here is 6, till here it is 8, till here it is 11. Right? But let me just keep the sums, the prefix sums. 6.
Actually, let's do the other way around. Let me tell you how to get the answer for this one, and probably you can come up with a solution, right?
All right. Yeah.
So for this one, you suppose decide to divide at 6, 2, 3, and 4, 5, 5. Right?
Got it.
So the left row will have the value of 11, and the right row will have the value of 14.
14.
Right?
Yeah.
So now what I'll do, I'll throw away the right row.
Yes.
And your score will now become 11.
Yeah.
Right. Now in the second round, what you will do, you will divide it into 6 and 2, 3.
6 and 2, 3, yes.
So this time I will throw away 6. And your score will increase by 2, 3, which is 5. So it will become 11 16. Plus 5, which is 16.
Yeah.
Right. Now we have 2, 3 remaining.
2, 3 remaining, right? Yes.
Yes. So now what I'll do, I'll throw away 3. So your score will now increase by 2.
Yes.
So your score will become 18, which will be 18. 16 plus 2.
Yeah, this will be my final answer.
Yes.
All right. Great. Yeah. So what I'm thinking is let us keep the prefix sums. So let's say if we have 6, then 8, and then 11, then 15, then 20 and 25. This will be the prefix sum. Let me just check this once. 8, 11, 15, 20, 25. So now I know that what's going to be the sum till a certain point. Now, yeah, let's say if I am dividing, I have several options to divide this array. So I can divide it from the first position. So that means 6 will be on the left side and remaining elements will be on the right side. Or what I can do is I can basically keep 2 elements to the left side and remaining elements on the right side and so on. So I have in total n number of options, right? So I can just keep doing this until I get the balance. The balance is basically I want to divide them in such a way that both the left part and the right part, the summation of both these parts is almost equal, as equal as possible. So I can basically find that balanced point in big O of n, and this would take and the same thing I'll have to do, I guess, because I'm dividing into 2 parts. I will have to do quite a number of times the same process. So in the worst case, it might be possible that I'm doing, and I will end up doing this n times. This will make it an n square solution. So can I know the constraints here? Like what are the constraints given to me? How many number of elements will be given to me?
So stone value can be up to 500.
Got it.
And stone value ka length, like the length of the number of the stones can be up to 500, but each value can be 10 power 6.
Got it. So yeah, total number of stones could be 500, right?
Yes.
All right. So in that case, I think n square is going to work. So yeah.
Okay.
So let us say
I have a question over here, Pras.
Yes.
So since you have decided to store the prefix sum, how will you be handling the discarding of half of the array?
Yeah, got it. So let us say, in the case when I'm discarding, in this case, I was discarding the right side. So I can simply discard this, right? I can simply discard this. It's not going to affect my prefix sum.
Right.
But let's say if I want to discard the left part, so in that case, I will have to remove the sum till this point. That was 11, right? Yes. I will have to remove it.
Yes.
So if I remove 11, that will make it 15 minus 11, 4, comma 20 minus 11, 9.
So you'll have to update the rest of the array
again and again. We'll have to update the rest of the array again and again. So basically, finding that balance point is going to take big O of n, and then updating will also take big O of n. So it is eventually big O of 2n, which is not going to increase the complexity. So solution will stay n square in that case.
Okay, got it.
Yeah.
Okay, can you walk me through how you'll be finding the balance point once?
Yes. So let's say this is the prefix sum array which we have. And if I want to keep one element to the left side and remaining element to the right side, in that case, my summation will be 6 for the left part, and for the right part, it will be 25 minus 6.
Yep.
25 minus 6 is 21. So it will be 21, right? This is how I'm going to distribute it.
25 minus 6 is nothing.
It is 19. Yeah. Now, let's say if I want to divide it from this point, so the summation on the left side will be 8, and on the right side will be 25 minus 8. That will be 17.
17.
Yeah. Next time, summation on the left side is 11, and on the right side is 25 minus 11. That will be how much? 14.
Yep.
Yep. Will be 14. Yeah. Next time, summation on the left side is 15, and summation on the right side is 25 minus 15, 10. Then 20, and 25 minus 25. Okay. So these are the possible configurations. And in this, the best one is here the difference. See, here the difference is going to be 13. Here the difference is 17 minus 8, 9. Here the difference is 14 minus 4, 3. Here the difference is, I'm talking about the absolute difference. So it is 5. And here the difference is 15, right? So this is the most balanced point.
The one with the minimum difference.
Yes, the one with the minimum difference.
Got it.
Yes. So first of all, I will find this prefix sum. Then I will find the balance point. After finding the balance point, I will discard the one with the maximum sum and will take the remaining part as my score, and then do the same process there from there. Yeah. Now there is one more point. How should I basically resolve the point when I have the zero difference? So in that case, you are letting me to decide, right? That which one should I pick? All right. So that is the tricky part, because it might, and my goal is to get the maximum sum, right? All right, so let us do one thing. Here, I don't think like I can go in a straightforward way. What I can do is instead of making this prefix sum array, because I am trying to find a balance point, I'm consuming big O of n time. I can basically count or calculate this on the go. I don't have to keep it. So what can I do is I can basically take the range of the row, the range of the indices, the left part and the right part. Initially, my range will be from the index 0 till the index 5. Okay. So this is the search space, or this is the space on which I have to perform the operation. Now in this space, I need to find the balance point. I can find the balance point. Let's say after finding the balance point, one choice is obvious. When one of the left part or the right part is maximum, I can go with that part. I can basically go in that direction. Or if they both are equal, in that case, I can basically have two choices. I can either go to the left part or to the right part. So I will try to explore both these possibilities with the help of recursion.
Okay.
And whatever is giving me the better answer, I will go with that.
Okay. Okay.
So yeah, and I can see that we might end up using dynamic programming here because we might be having some overlaps.
Right. So basically, you move from prefix sum to recursive solution to handle the equal scenario, and
Yes.
then from recursion, you are saying you might need dynamic programming.
Yes.
Which is good. Sounds good to me.
Yeah.
Okay. Do you want to write the recursive solution first, or would you be able to write the DP solution to it?
So I will be writing the recursive solution, then I will try to optimize it using memoization.
Got it. Sure.
Yeah. All right. So it's going to give me an integer answer, and let us name this function as score.
No, you don't have to worry about capitalization. It's fine.
Got it. This is my left side. This is my right side. So I will also need the vector. Stones. And then what else do we need? I will just keep adding things. Whatever I need, I will just keep adding. So first of all, when only one stone is left, so in that case, I should stop, right? So when L is equal to R, only one stone is left, and I should return the answer from here. The answer is stones of L or R. Okay.
Yep.
Yeah. Next, now let us try to calculate the sum of the left part and sum of the right part and every possible distribution, and try to find out that which distribution is the most balanced. Int left sum, initializing this with 0. Right sum, initializing this with 0. Int I. So this index is going to start from left. Let me run a for loop here. For int I is equal to left, I is smaller than equal to right. It will be smaller than right because we need at least one element on the left side or the right side. And I plus plus. So from the point L, from the index L to the index I is going to be on the left side. So first of all, let me update the left sum plus equal to stones of I. Okay, updated the left sum. So now I have a specific left sum. I should also know what is the right sum till this point. So let me just keep the right sum. For the right sum, I'm again going to run a for loop. Initially, the right sum is going to be everything which is in the space from L to R. So I'm just going to keep the summation. Int I is equal to 0. Not I is 0. I is equal to L. I is smaller than equal to R. I plus plus. Right sum plus equal to stones of I. Basically, I'm just putting everything into the right side as of now.
Right.
So, yeah. Now, from the index L to the index I, these stones are moving to the left part. So left sum is going to be incremented, and the right sum is going to be decremented.
I have a question. So
Yeah.
here you're calculating right sum separately and left sum separately in two different for loops. At a particular instance, like at a particular I level, you want right sum and left sum to be able to compare them, right? So
Yes.
do you have like a total minus left sum equal to right sum to be able to compare at a particular value?
Can you please repeat the last point?
So here you are going through the right sum and the left sum, but to
Yeah.
be able to compare the left sum and the right sum at one particular point, like at a particular I, you need the value at one particular point, right? To be able to compare
Yes.
them.
Yes.
So shouldn't you like have a total sum minus left sum equal to right sum? Wouldn't that be better?
Yes, that would be, yeah. So that this actually was my total sum. This right sum is going to behave as my total sum in the initial part. And then I will just keep reducing. So yeah, I can take the total sum. Like it's just the change of name. I can take the total sum here.
Okay, so we're actually calling it was actually total sum. You were just
Yes.
calling it that. Okay. Got
Yes.
it.
Yes.
Okay.
So now it is the total sum. Okay. And now to compare it, what I can do is I can keep the difference. So I need to check difference at every point. What is the absolute difference? So int absolute difference, initializing this with int max value. Okay. Also, I should keep track at what is my breaking point? What is my balance point? Balanced point.
So what value are going to store in this balance point?
So this value is going to be, let us say, at the index 5. This is giving me the best balance point. I mean, the least absolute difference.
So you're going to store the value of I or the difference in the balance point? That's what I'm asking.
I'm going to store the value of I.
I, okay.
Yeah.
Got it.
So initializing this with, again, -1.
Okay.
So yeah, now it might be possible when the difference is 0. So if the difference is 0, yeah, I will. Okay, I'll just make sure to check for that condition as well. So yeah, now I need to see what the difference is. If absolute of left sum minus the right sum. The right sum is total sum minus left sum. So this is the absolute difference of left sum and right sum. If this difference is smaller than the absolute difference, okay. What if we have the same absolute difference at two different locations?
That was the case because of which you moved to.
Yeah. Yeah, so there could be a case when both the parts are left part and right part are balanced, actually balanced. And then there could be a case when I can have two possible configurations, of the left part and the right part. The difference of the left part and the right part are same. So these two configurations should also be handled apart from equal sums. So in that case, would it be In that case, what I can do is I can basically go for every possibility. I can go for every possibility here.
Okay.
Yeah. This is the summation of left part. This is the summation of right part. And I'm going to break at every I and then ask recursion to give me the answer for specific parts. But, all right. All right. So let me calculate the right sum over here. Right sum is total sum minus the left sum. Okay. Yeah. So if the right sum is greater than left sum, here I'm assuming that the left sum is actually smaller. Then there could be another case when the left sum is greater than the right sum. And then there can be another case when they both are equal. Right?
Yeah.
So here what I can do is, because the right side is greater, I should, you are going to discard the right side. So I will be left with the left part only. So the left part is from L till I, right?
Right.
So I will ask recursion to bring me the answer for that part. So the function's name is score. Left part is going to be L, right part is going to be I, and stones. This will bring me the answer.
Yep.
Answer is equal to maximum of answer comma this. Okay. Now here the left part is actually of greater value.
Where did you initialize your answer?
So yeah, let me initialize my answer here. I'm just going to discard all those variables which I'm not using. Initially the answer is 0. Yeah. So here answer is equal to maximum of answer comma score of the right side. Right side is going to start from I plus 1 till R.
Yep.
And here I have to see both the possible options. Answer is equal to maximum of answer comma. First option is score of L comma I comma stones. Actually, the battery is going to die in a few minutes.
You can record from your phone?
Yeah, I will be recording from my phone then. So I plus 1 comma R comma scores stones.
Flash, if you want, you can pause and switch to phone, like to make sure we don't lose any record.
All right. So let us switch to the phone. All right. Yeah. So where were we? Yes. Yeah, here we need to explore both the possibilities. So answer is equal to maximum of answer comma, going to the left side, then going to the right side. And because we are putting these 3 values, just want to keep them inside the curly braces. Okay. After this for loop, I can return the answer. That will be the most optimal answer, the maximum answer. And I don't need to keep this difference, and I don't need to keep this balance point, because now I'm exploring every possible option.
Okay. Yeah, so you can just go through it once and then I'll ask you a question.
Yes. So I'm writing a function. I'm taking the left side and the right side and stones. The base condition is if left is equal to right, then return that, basically to stop when we have only 1 stone remaining. Then the left sum is 0, the total sum is 0, initializing the total sum as the summation of all the stones here. Then initializing the answer, then going to each and every possible breakpoint and calculate the left sum. This is going to be the left sum from L till I. This is going to be the right sum from total minus left sum. Then if right sum is greater, we are going to discard right side and we are going to, okay. Yeah, one more thing. Yeah, I need to calculate the score, and the score will be
Right.
the lesser
You
side.
need to return the score, not just
Yes.
the.
Yes, correct. So yeah. So in that case, here the score will be left sum plus the maximum from the future, and here right sum plus the maximum from the future, and here because they both are same, so I can take anything.
So your answer is basically the score, right?
Yes, my answer will be the score.
Okay, now I have a question. So when you're doing left sum plus maximum of answer and score, shouldn't it be maximum of answer and left sum plus a score? Because in answer you have the previous score.
Correct. Because in answer I have the answer for the previous iteration. Now for this iteration, it should be the maximum of previous iteration, comma, the left sum plus maximum of these two things.
Yep.
So let me just get rid of this curly braces. Okay. Maximum of this. Yeah. And here also, let me just remove this maximum of previous answer, comma, the right sum plus the future score, and maximum of previous plus the future score. Yes.
Right. So now what's the time complexity?
Yeah. So basically, we are going to go to all the possible left and right. So there could be, let's say, let us assume that the size of the given array is n. So for L, there could be n possibilities. For R, there could be n possibilities. So it is going to be n square if we talk about this recursion. But then inside each one of this configuration, we are again running a for loop. Okay, we are again running two for loops actually. So that will include extra n. So it is going to be n cube.
And since you're recursively calling it, are you sure it is going to be n cube only?
Because we have the possible configuration of left and right is going to be n square. There could be n square possible configurations, and
right. N square, and then within n square, again you're going to call n square. Again within that, you're going to call n square again within that, right? It's just going to become from n square to n by 2 square.
Yeah, I got it. So basically, yeah, it is going to become exponential in that case. But I was just assuming that we are going to have distinct configurations of L and R. So we are not going to repeat that. We will just memorize it, and then we are not going to go back again to the same configuration of L, R.
Right. Right now, I'm talking about recursive solution, since that's what you have written.
Yes. So yeah, it will be exponential because we will again be exploring n square and then again n square. So it will become exponential. And let me try to just evaluate the exact complexity. So n square total configurations and total configurations, and inside each of the configuration we are having call of n. So n square raised to the power of n, maybe, I'm not sure about it. N square raised to the power of n.
Okay, basically exponential.
Exponential.
We can get to the memoization part.
Yeah. So now, because so many states will be overlapping and it will be repeating, so the combination of L and R is going to repeat again and again. So in that case, we can use memoization, and we can use a 2D matrix here to basically store the answer for every possible configuration of L, R. So that's what I'm going to do. I'm going to have a vector of int dp, and this will be of the configuration n cross n. So let's say if I have already, and initially I will initialize all these cells of this dp with -1, because -1 is not going to be our score. So we can safely assume -1 initially. This -1 will denote that the this configuration is never been reached in the past. So in the past, if this L, R is not reached, it will be -1. Otherwise, it will be something else. It will not be -1. If it is not -1, then we are simply going to return the DP of L, R. We are not going to reevaluate again using these steps. We will simply return it from here. So this is done. And when we are returning, we will simply save this answer so that we can use it in future. And the necessary changes should be made in these function calls. Scores, DP. Yes. Yeah. So I think we are done with this.
Okay.
Yes. So yeah, now the extra space will be required. The n square extra space will be required because of this DP. And the time complexity will now improve and it will become n cube because we are going to have a total n square distinct configurations. And in each configuration, we are again running a for loop.
Okay, got it. Give me 1 second to go through the code.
Yeah.
Okay, so you're keeping answers separately, and that is basically your DP of ij. So you are assigning it in the end. Okay, yeah, this works for me. Great. I have another question, just like a follow-up question. So in the starting, you chose to not use the prefix sum and you chose to use this. Suppose you still went ahead with prefix sum, would you have been able to handle the code or not? And if yes, what changes you would have to make?
All right. So using the prefix sum, actually, I had this in mind that I will not have to recalculate the sum again and again. But then I was always trying to figure out that balanced point. So at the end, I was using big O of an extra time to find out that balance point. So keeping a prefix sum was not giving me an advantage. Also, at the same time, I was going in a straightforward way that at every point I already know that which decision I have to make. But then I got to know that I don't exactly know that which decision should I go for. So that's why I try to explore both the possibilities. So just in case you let me know that what decision should I make when I have a conflict, when I have the left part and the right part same, and if you just let me know that which part should I go with, in that case, I can go in a straightforward way and I will not have to explore all the possibilities.
Right. Just to make this video a bit more interesting. So this works for me, interview-wise, this is great. So this is top-down DP, right? You have just memoized.
Yes, yes.
Can we try to do bottom-up DP also of the same question?
Yeah. So yes, we can see how we are actually filling this. So basically converting it from top-down to bottom-up, we just need to figure out that how are we actually filling our DP. So our DP is of size n cross n, right? And we are starting with L as 0 and R as n minus 1. So for simplicity, let us assume that our R is equal to 3. Okay, we have a 4 cross 4 matrix, and yeah. So here, initially, we should fill the base conditions. When L is equal to R, so these base conditions actually means the diagonal. So we should fill these diagonals. And this diagonal will actually be all the values inside the stone array, right? So we can fill all these values. So let us say the values of inside the stone array are 1, 3, 2, and 4. And I will be filling 1, 3, 2, and 4. I will just write the code. I'm just trying to basically break this down.
Yeah, that's
after that I will write the code. Yeah. So after that, now let us come to this for loop. Yeah. Now I'm trying to break it down at each point, starting with, initially I will have to start with I is equal to 0 because L will be 0 initially. So yes, So when it is equal to 0, I will be able to fill the, I will run a for loop, and in that for loop, I will go to each and every possibility. And which position am I initially filling? I will be filling the position 0, 3, which actually means the first row and the last column. So I will be filling the first row and the last column first.
That will be your answer.
No.
First row and
yeah, that will be my
last
answer.
one.
And that is something that I will not be filling right now. For that, I have to reach to the intermediate steps.
Yes.
Now, yeah, for the intermediate steps, what we are doing is, say this is 0, this is 0, 1. Yeah. From the point 0.
Basically,
so
sorry.
Yeah. So yeah, we can fill the first row and the second column. So the cell 0, 1 here. So we can fill this cell. So this basically means that we are discarding the part from the index number 2 till the end, and we are just considering the part from the index number 0 till index number 1. So which basically means that we are taking the summation till this point. We are taking up the summation from 0 to 1, and the remaining part from 2 to 3 we are discarding, so we can ignore that. So the summation will be 1 plus 3. In my example, it will be 4. 4 will be there, but then for that we need to evaluate. Just give me a moment.
Sure.
So yeah. If we are talking about 0 to 1, we have only 2 elements here. The first element is 1, second element is 3. For this, we can either remove the left part or the right part. So we can actually get to know that which sum is more. So yeah, whichever is less, I will take that and plus the summation. Yeah, so I can take 1 here, 1. Plus whatever is left. Got it. Yeah. So what I can do is basically now I can go to 2 elements at a time. I've already covered 1 element at a time. Now I can go to 2 elements at a time. So if I go to 2 elements at a time, and if I talk about the index 0, 1, which is the first row and the second column. So in that case, I have 2 elements with me. That is the index number 0 and the index number 1. Now here the decision is to basically take the left part or the right part. So if I will basically be able to compare that what is the summation of the left part and what is the summation of the right part. So after evaluating the summation, when the left part summation is coming out to be 1, the right part summation is coming out to be 3. Okay, for that I'm running a loop. So 1 and 3, these are the 2 summations. Of course, I will pick up the smaller one, so I will pick up 1. Okay, and because I'm picking up 1, I am going with 0, 0. I'm going with the cell 0, 0. So because I'm going to go with the cell 0, 0, I will take whatever is already there at the cell 0, 0 as the answer, and I will add that 2. So the summation will become 2. So yes, I think we can write this down. So similarly, I will go to 2 elements each time.
Basically,
if you want, I can
going
show
lengthwise. So you'll be starting from the length of the array from 1 element to 2 element, 3 elements, like that, up to n elements, right?
Yeah. So basically, I'm filling up the diagonals.
Yes.
Yes. Yeah. So to fill up the diagonals, I can run a for loop for int I is equal to 0. I smaller than n, I plus plus.
This is a length. What is this?
This is the row. Which row am I talking about?
Okay.
Yes. J is equal to 0. So this is the column, which should be equal to the row itself. But here, all right. So the columns loop should be for int j is equal to 0, j smaller than the row, j smaller than equal to I, j plus plus. So this way I will be able to go to all the diagonal elements. So when I is equal to 0, j will go from 0 till, j is going to go from 0 to 0, should go till,
So you're filling the lower diagonal value of the.
actually I'm filling the upper diagonal. So
But-
basically the upper right.
But according to the for loop conditions that you've written, it is not upper right.
The lower one.
Yeah.
So I is equal to 0. We're going to go to each row.
Let me help you out a bit over here. So the outer for loop, you can have it of length. So length equal to 1 to n. And the inner loop you can have from I equal to like whatever. So your j value will essentially become I plus L minus 1.
All right. So I can run a for loop for, let's say, level from 0 till n.
1 to n also makes sense because it's just the length, right? So
yeah,
just make things
smaller than
easier.
equal to n. And length plus plus. So this is going to be my length.
Yes.
And then inside, like for each length, I can run the for loop.
Yes. And that's going to start from 0 itself. Now your j just becomes I plus L minus 1.
Yeah. Int j is equal to I plus L minus 1. So this way I will be able to go to each of the values of the upper diagonal. So let's say if I'm talking about the L is equal to 1, so I will go from 0 till n, and initially my j will be equal to 0 plus 1 minus 1, that is 0. Then it will be 1 plus 1, 2 minus 1, that is 1, 1 comma 1. Yeah, I will be able to go diagonally, right? Yeah, great. Now I can start filling this up. So to fill it up, I need to know the summation of the left part and the right part. So basically this L, this I and J is going to denote my left side and the right side. So I can run a for loop int k is equal to I, k is smaller than equal to j, and k plus plus.
Yep. This is the dividing part.
This is the dividing part. This is exactly this part. This one.
It's doing the job of I in this case. Yeah.
Yeah, it is going to do the job of I. Let me just copy this part. It's going to help me a bit over here. Oh, no, it will disturb the indentation. Let us just keep it as it is. So make my answer over here. This answer is initialized with 0. Okay. Now, keeping the left sum and the right sum, I'm just trying to make it as similar to the top down.
Yeah. Got it.
So just this thing, I can just simply copy it from here. Okay. So this is going to be the left sum. This is going to be the total sum. Total sum is this. Left sum is 0 initially. Now I need to make changes to the left sum. Left sum plus equal to the stones of k. Int right sum is equal to the total sum minus left sum. This is the right sum. Okay. So we have calculated this. Now these are the 3 situations. These are the 3 conditions that we need to put over here. So the first condition is when the right sum is greater than the left sum. In that case, answer will be equal to maximum of answer comma left sum plus scores of L comma. Instead of scores, I can use the DP here.
Right.
dp of this was L comma I. So for L we have I. This is the left part.
I to K basically.
Yeah, and for this I we have this K. So I to K. dp of I comma K. Okay, let's move this one. So for the second condition, it is when the right side is smaller, so answer is equal to maximum of answer comma right sum plus I plus 1 till R. So J represents R and I plus 1 is K plus 1. K plus 1 and this is J. Okay. Else answer is equal to maximum of answer comma left sum plus maximum of then these two options are going to be there. dp of I comma K and dp of K plus 1 comma J. Yeah. And
Okay.
then we can save the answer. Yeah, after this for loop, dp of I comma J is equal to the answer. And then we can proceed to the next configuration.
There is one mistake that you have done. I will give you a minute to go through it and let me know.
Yeah. So I think first we need to fill the base conditions. I forgot to fill the base
Yes,
conditions as
that
well.
is also there. Yeah.
Yeah. For I is equal to 0, I is smaller than n, I plus plus, dp of I comma I. So this is the first initial diagonal, right?
Mhm.
Initial diagonal. Then we can start with L is equal to 2. If I already fill the initial diagonal.
Right.
This is going to be stones of I.
Is it going to be stones of I? Because we are actually going to throw away the bigger one. Right?
Because we are only left with one element here, right? So we can,
Yeah.
I guess we can assume stones of I there.
So when there
because
is
we are
one
left-
element, according to the question, what like when the input is just one element?
Oh, is that so? We have to
Because
return. Correct. We should not take anything in that case, right? So yeah, we should
actually
not
over
take anything
here
in that
also
case.
it should be 0.
Yeah, here also it should be 0, and stones. This here also it should be 0. Yeah.
There's still one thing that is wrong.
Yes. I'm just having a look at that. So I is equal to 0, I smaller than n I plus plus, J is equal to this, int answer is equal to 0, left part in the total sum. Int okay, I is equal to L smaller than. Actually, this will not. Let me also change the variable name here as well. Let's assume it at K. K is equal to K plus plus. K plus plus K. Then for K is equal to I, K is smaller than J and K plus plus.
Okay.
It should be smaller because, yeah.
Why smaller?
Because we need to consider at least one element on the right side.
At least one element on the right side. So if you are.
And the distribution is from
so it
I
was,
till K.
say it was like 0, 1, 2. Your K value goes from 0 to 1. Like it won't be 2, right?
Yes.
Okay, so if it is not 2, then aren't you going to miss the case where your left, okay, 1 second, it's from 0 to 1. And you're taking from K plus 1 to J. Give me a minute to think about that. I think you're missing one case over there. dp of I to K you're taking and K plus 1 to J you're taking and making sure that there's at least one element over there. So, okay, this works. Yep. So
Yeah.
instead of that, what I had in mind was that you would do k less than or equal to j. And in that case, when you were doing dp of k plus 1 to j, it would have gone out of bounds.
Overflown. Yeah, but I
overflow.
think that will not arrive. That case is not going to arrive.
Yeah, because you now did that k less than j. Yep.
Yes.
Works. This looks great. We can get to the feedback part now.
So Fras, tell me about your experience of the interview. How did it feel, and any feedback for me?
Yeah, so I was actually giving an interview after a few months, so it was a really good experience. And yeah, you were a really calm interviewer. You were able to tell me, pinpoint a few of the problems which I was facing during the coding part. Also, initially I started with a wrong approach. I took the wrong approach in the initial 10 minutes, I guess. Then it suddenly, all of a sudden, it struck that yeah, we are going the wrong direction and we need to explore out all the possibilities. So quickly change the approach. But yes, you were really good at interviewing. And now, are there any feedbacks for me?
So learning wise, firstly, the video will be very good for the students, I feel, because in the starting we started from a very conventional approach. Then we realized, okay, it's not going to work. Then we moved to recursive. Then we discussed why and how are we going to convert it into DP. And then from DP also, from top down to we went to bottom up. So I think it's a very good structure, and this is how students should think also. So I think learning wise, this is a great video. Other than that, for you, I felt you were so calm and confident. Like even though when you were making mistake, you were taking it up, and you knew that okay, where you are going wrong, exactly the edge cases. Like it's not possible that in the interview, especially if you're giving after 2 to 3 months, to be able to handle like everything in months, and especially when you're doing it for YouTube, there's even more pressure. So I understand that. But still, when I told you, you were handling it in a very, very confident and calm way. So that was very impressive. Your communication skills really impressed me. Like you were very crisp and clear. Even when you were writing, you were communicating it so well that I could actually picture what you're writing. You were saying it so well, right? So that's what I keep telling people, that you don't have to, keep showing the paper or keep writing on the screen itself. As long as you are saying it out aloud, and as long as you're able to explain what you're thinking, it's good to go. Like not even once did I lose the track of what you're doing, or did I lose, that was not even once that I was thinking that you were going in the wrong direction. So in that case, I felt that, it was a really good interview.
Thanks a lot, Keerti. Thanks a lot for the feedbacks as well.
One small thing that I felt could have been improved, because I have to give improvement feedback as well, right? That is, I understand that from recursive to DP, it's very easy, top to bottom works, and most of the interviewers are fine with it. But don't leave bottom up as it is, because I could see that, you have less practice in bottom up, because of which in the for loop conditions also you were struggling a bit.
Correct.
For me, it's the opposite case. When I have to convert the recursive to DP, I keep thinking a bit like, am I making any mistake? But I'm used to the bottom up thing. So it's opposite for us, but the ideal thing should be that you should be able to write both. So to those who are new to DP, for those who are practicing, I would suggest that, practice both the ways, because you should be able to write both.
Yeah, the trickiest part is traversing those diagonals. Like once you recognize that how you are going to fill the matrix, or how you are going to fill the 3D DP that you have formed, so the only part left is the traversal, and it should be there in your mind that how you are going to traverse this. What is the exact expression that you use to traverse this? Otherwise, it will take some time to get in interviews, and you already are nervous. You already have pressure during the interview, so it becomes a little bit tricky to find it out. And the same happened with me.
Exactly. So this actually, some people call this method of traversing as gap method, because you are going in terms of length equal to 1, 2, 3.
Yeah.
So yeah, there are a lot of questions based on this. So guys, go practice those questions.
Definitely.
Yeah. Thank you so much for being such a sport and coming over here. Fras means a lot. Thank you so much.
Thank you so much, Keerti.